this giant seawall showing in the picture below. If for the northern part of Jakarta. And next page, please. Yeah. What I happened to see this magazine article from one of the magazines. It says the city is sinking due to massive groundwater extraction. So at the rate of 25 centimeters per year, so 4 million people are 4 meters below the sea level. So in other words, in Jakarta, you're also having the settlement problems. So your ground is settling. In addition to this, next slide. Well, similar to Singapore, you also have clean water problem. You have a space problem. Where people need better living conditions. Of course, you have sea level rise. You have flooding problems. The next slide. So I think the giant seawall is a very good solution. So yeah, combines coastal reservoir, coastal defense system, as well as clean water and space for more buildings, more commercial or residential buildings to be constructed. Except so this plan looks like too ambitious to be completed in one go. Next slide, please. Yeah. Well, since today we are discussing geotechnical problems, so if we have to build the giant seawall in Jakarta, we have to deal with the following geotechnical problems. We have to construct the seawall, we have to construct the coastal reservoir, we have to do land reclamation for land, and we also have to build the road, build the floodgates. And remember, all of those have to be on soft seabed sediments. And in addition to this, we have to deal with waste proposal, with river dredging and river cleaning. So all of those need soil improvement. Next. So that leads to the topic for today, how to do soil improvement for coastal protection and the coastal infrastructure. While there are many topics as I've just listed, so I'm only going to zoom into two topics. The first one is the seawall construction on soft ground. The second one is the land reclamation using dredged soft materials. Next. Yeah, now let's start with the land reclamation. Many of you are familiar with the land reclamation. So basically, we have to put soil, mainly sand, on the seabed and to form a platform which is above the mean sea level. And from there, we have to treat the soft soil and reduce the settlement, increase the bearing capacity before we can build our cities on top. And next. Well, one of the tasks which we may have to do for Jakarta is to dredge the 13 rivers, and then the dredged sediments or the dredged materials can be used as a fuel materials for land reclamation. Next page. However, the use of soft soil, or particularly mud or slurry for land reclamation, is difficult, and simply because the top is too soft for workers or machines to go on top to carry out soil improvement work. So the key technical challenge is how to form a working platform then for workers and the machineries to go on top. And there are a number of methods. But however, in my opinion, the method to be used is the one with the lowest unit cost. Now you can imagine if for 1 cubic meter of soil, you can save, let's say, 10 ringgits. You can, for there are millions of cubic meters, you can save millions of ringgits. Next page. Well, there are several methods. The one which have been proposed is Professor Brahms' method. Professor Brahms was my former boss, and this is by the so-called finger methods. Okay, and with a layer of geotextile below. But then this method is very clear in concept, but sometimes it may be difficult to implement. The next page. So recently we have modified this method by using gel tubes to form the so-called fingers. So this may enhance a little bit of construction control. Next page. Next page. Yeah, my PhD student has developed various solutions to be used for design. The next page. We have also carried out some trials to see whether this method is effective when it's used for a real project. Next page. Another way is to use bamboo matrix or bamboo fasin. So I believe our Indonesian friends has many experiences on this. Next page. Well, in fact, the methods which I would like to propose is a so-called two-stage construction method. And stage number one is just to form a working platform by treating the top 4 to 5 meters of slurry. And then once the working platform is formed, and then you can go on top to do the conventional soil improvement. This is supposed to be animation, but because I will not be able to show my own script, so I don't think this animation can be played. Next slide. Yeah, so I'm going to skip this. Next slide. Yeah. Well, basically the key of the proposed method, which I will not be able to explain in detail, is the installation of so-called short PVD from the mud. As you can see from here, you can actually install 4 to 5 meters of PVD from water or from slurry. So the way to do it is use very light either machines, installation machines showing over here, or you just use a stick. A stick, you will be able to push in the PVD into the ground because the soil has no resistance. Next slide. Next page. Yeah. Then after that, you can cover the top. You can use a vacuum preloading to improve the top 4 or 5 meters using the PVD and the vacuum preloading. And next page. Yeah. But however, there are difficulties in the use of PVD for land reclamation when soft mud or soft soil is used. Firstly, we need to form a working platform, which is difficult and time-consuming. And second, soil improvement can only be carried out after all the fill materials has been placed and the working platform has to be formed. So in other words, you have to wait, until the filling has been completed. This can take, many months or many years. Third is difficult to design. It's due to larger compressibility and more fill materials need to be placed and more consolidation. So in other words, your ground is always settling. So it's difficult for you to really estimate how much is the settlement. So in other words, it's difficult for you to do the design. If you are using vacuum can only be applied section by section. So sometimes you may need partitions in between. So this will increase your construction cost. Another limitation is the vacuum pressure is only limited to 80 kPa. Next page. In addition to what I have said, there are other limitations with vertical drain. And for example, the effect of clogging. And this is something which we tend to neglect. But as a study shown by Professor Cai from China, you can see the clogging plays a major role in controlling the consolidation progress. So if you look at the degree of consolidation versus time, you can see the different curves, and they are very much affected by whether the drain will be clogged. You see, without a clogging zone, let's say for a given time, you may be able to achieve 80% of degree of consolidation, but just due to clogging, your degree of consolidation can be much reduced. So look from here, you can reduce from 80% somewhere to 40%. Next page. Of course, there are other new methods which may be able to improve the performance of PVD. Again, Professor Tsai, and so they have the so-called air booster method. So to improve the performance of PVD to a certain extent. Next page. But however, since we have to put the fields layer by layer, as in our case, so the probably a better alternative is to use horizontal drains and rather than vertical drain. Next slide. Yeah. So for this purpose, we have developed the so-called horizontal drain enhanced geotextile sheet. Well, again, that's an animation, but however, I will not be able to show the animation because of the technical problems. So basically, we had to put the so-called horizontal drain enhanced geotextile sheet and layer by layer into the seabed. For the first layer, it's installed on top of the seabed, then it's covered with the mud. So once the geotextile with horizontal drains are covered by mud, you will be able to start to use a vacuum to vacuum the soil which is on top of this layer of horizontal drain. And in this way, you will be able to treat the soil soon after several meters of fuel has been placed, while you are depositing the other layers of mud. So in this way, and by the time your fuel has been placed near the ground surface, and the bottom part of the soil has been more or less improved. Next page. Yeah. So we actually have done many laboratory large scale model tests to demonstrate, and the concept will work. This is the equipment used. And next page. With kaolin, we can actually achieve almost 90% degree of consolidation within 3 days. I have to say, kaolin has a relatively high permeability, but then as a demonstration of the concept, this basically show it will work. Yeah, and the next slide. Yeah, as a result, we will be able to reduce the slurry with the water content of nearly 100% to somewhere around 55%, and we will be able to increase the undrained shear strength from 0 to somewhere around 30 kPa just after 3 days or 30 hours of consolidation in this case. With just one layer of horizontal drain. In fact, over here is just one PVD but put in the horizontal direction. Yeah. Next slide. Yeah, we actually have carried out many more other in-depth studies, but because of time, I will not be able to discuss more on the testing results. Next slide. Yeah. Then what are the advantages of the so-called horizontal drain methods? Number one, the vacuum pressure can be applied layer by layer and while the fill materials are placed. And number two, the fuels on top of the horizontal drains becomes the surcharge. And number three, as no sun fuel is required because we don't need to operate on top. So what we need is just use horizontal drains and to consolidate the soil layer by layer. And you can save a substantial amount of time because while you are placing your fuel, and the soil can be improved. And by the time the fuel has been fully placed or has been placed up to the required elevation, and most of the soil has already been consolidated. It is more reliable in predicting the settlement because once the first layer of clay has been consolidated, you will be able to use the measured settlement to back calculate the consolidation parameters and use it to predict the consolidation of the subsequent layers. And you don't need partition. But however, it does has one disadvantage. That is, you need to install the horizontal dream blanket layer by layer. Yeah, next slide. Okay, now let's share a little bit on the seawall construction. Yeah. Well, in shallow water, we can have other more innovative methods for seawall construction. For example, the use of gel bag for a shallow seawall or sea dike constructed along the coastal areas for protection. Showing the picture on the right is from the east coast of Singapore. Next slide. But of course, when we have to install seawalls in relatively deep water, for the case of giant seawall for Jakarta, we will not be able to use our conventional method, and we may have to use the concrete caissons as showing over here. So the construction method for the concrete caisson is we cast the concrete caisson box in a dry dock, then we tow to the place where it needs to be installed. Then we install onto the seabed. Next slide. But the only problem is when the seabed is soft, and you will have to improve the seabed soil. So one of the conventional ways is to dig out the soft mud or soft marine clay and replace it by gravels or sand, so-called the sand key. And then on top, you can put your rubber mount before you can put your seawall on top. If we are adopting this method, then we have to involve intensive, ground improvement. Another way is to use a suction caisson, as shown in the bottom picture on the left. So instead of do dredging and to do replacement, what we can do is, we suck concrete cylinder using suction into the ground, and then this concrete cylinder will provide a strong foundation for the seawall on top. And in terms of construction, we can actually assemble the seawall and the suction caissons in the casting yard, then tow it to the construction site for installation. So in this way, and the construction quality will be ensured, and also the construction speed can be accelerated. And next slide. The suction caisson is actually not a new concept. It has been adopted for offshore platform and also for wind turbines in the past. And showing here as a picture is 3 metal cylinders to support a monopole wind turbine. The principle of the suction caisson is to apply a suction within the cylinder, and the suction will be able to suck the whole cylinders into the seabed. Of course, in this process, we'll have to overcome initially the set friction. So in other words, you need to provide a sufficient suction. Once the suction caisson has been installed, and we rely on the set friction to provide the bearing capacity. So in other words, the bearing capacity can be easily calculated based on the available friction. Next slide. Yeah. In fact, we have carried out extensive study in the previous project, and we have a consolidation tank of 6 to 6 meters, and we are using a suction caisson of 1 meter in diameter, 1.5 meter in height. We have developed a construction installation procedure. Next slide. Yeah. So basically, we propose to use 4 cylinders as a foundation. And the reason why we use 4 cylinders is because once we suck the cylinders on the ground, if there's any eccentricity, if there's any tilting, we will be able by adjusting the pressure to overcome or to balance the tilting. And then, as I mentioned, the top seawall and the bottom cylinders are actually assembled together in the casting yard before it's towed into the location to be installed. So if you link them together, and then they form a nicely seawall. And next slide. I actually have an animation to illustrate the construction process. Again, I will not be able to play this time. Next slide. Yeah. So as a summary, integrated coastal protection and infrastructure development is a way to go and to tackle rising sea level and overcome major challenges in urban flooding, clean water, and space creation. So soil improvement methods for land reclamation using dredged soft clay are proposed. And methods for seawall construction are also introduced. Yeah. Next slide. Well, with this, completed my presentation. I would like to thank all my PhD students, researchers, in particular Dr. Wu, Dr. Li, Dr. Guo, Dr. Chen, for the great contribution. I also like to thank my funding agencies and thank Thalib Construction for the support. Yeah. Thank you very much.
Okay, thank you. Very interesting, Professor Chu Jian. So with the integrated coastal protection and coastal infrastructure and some proposed for the soil improvement. So before continue to the discussion, so we have a presentation from the sponsorship. Please, Keller, make a presentation.